Okay, students, good morning. Is my voice coming? Rain and others. Harsh, Virat, आवाज आ रही है मेरी? Is my voice coming? Yes or no? I am audible to everyone. Yes or no? Okay, so we'll wait. Only two, three students are there. We'll wait for 2, 3 minutes. 2 minutes we'll wait. Then everyone will join, and then I'll start the lecture of hydroil oil and properties. By the time, if anyone has any particular thing to ask, you can ask now. If anyone wants to ask, you want to discuss anything, you can discuss now. किसी को कुछ पूछना है तो you can ask now. Okay, students. So I am going to start. Let others join in between. So last time I have discussed in the lecture about the hydraulic components, and I've shown you the different particular videos regarding about the oil hydraulics, how the hydraulic system will work, and different particular things we have discussed. Let me have the PPT which will on. So I discussed with you last turn about the machines, the introductory of the machines that requires some type of power source and a way of transmitting this power to the point of operation. So how the different machines are being used, like if you see the mechanical machines like the belt drives, or maybe the electrical machines like the electrical transmission system, or maybe the excavators. 1 minute, student, 1 minute. Okay, student. So last time I have discussed with you about the three methods of the transmitting power. One method is through mechanical means, like if you consider the belt drive, which is a part of the mechanical system. So that is the reason, like how okay, the reason like how you can able to uh, so that is the reason like how you can able to transmit the power uh, for this particular purpose. So that is the reason for the transmission of power from one place to another to this particular system. So how you can able to carry out the things in a proper way. Then the next particular method, now it is coming, Kinjal. Now our voice is coming properly. Yes or no? Now the voice is coming. Yes or no? Okay. So next is the electrical power. So how the electrical power is being transmitted through the wires and all through this relaying system, and how you can able to manage the proper way of the things. And next is the fluid system, where we are using the hydraulics, we are using the pneumatics, and with the help of the hydraulic system, which is being used to take up the heavy load, and the pressure generated by the hydraulic system is more than 1000 bar, while if we compare the pressure generated by the pneumatic system, it will be 5 to 10 bar. So lighter components can be taken up, but the system will work in a faster manner. But if we compare the hydraulic system, we can able to get the precise control of speed, which we cannot able to get it in the pneumatic system, because it is having a very fast way of working. So that is the reason like we are having this particular power transmission. So next I discuss with you about the that like air is compressible. So this describe whether it is possible to force an object into a smaller space than it normally occupies. So for example, if you compare a sponge, so a sponge is compressible because it can be squeezed into a smaller size. But if you compare the liquid, which is incompressible, that is opposite to the compressible. So when a squeezing force is applied to an object, it does not change to a smaller size. So when you apply a squeezing force to an object, it will not change to a small size. So liquid, for example, hydraulic possesses this particular physical property. So what is basically the fluid power is a method of using the pressurized fluid to transmit energy. So maybe if your medium of the pressurized air is through maybe hydraulic, which is maybe hydraulic oil, or maybe pneumatic, which is a compressed air, then it may be like liquid or gas, which is referred here as a fluid. And according to the two branches of the fluid power, pneumatics and hydraulics will be there. So what is a hydraulic system? So hydraulic system uses liquid to transfer force from one plane to another, while if we compare it with the pneumatic system, that is use air to transfer the force from one point to another. So that is the reason like how you can able to have the transfer of the that force, which will makes the things to move in a manner so that it can be properly made to flow from one place to another. So today I will show the videos of how this hydraulic and pneumatic system will be applied in the robotics, which is being used in the industries for various applications. Like if we compare the robotics which is being used in the industry for welding purpose or for the material handling purpose and for the other purposes, then how these particular things will be done, and how the hydraulic systems and pneumatic systems when applied to the robots will make the system more and more efficient. And why it is important to have this use of the hydraulics and pneumatics in a proper way for the today's industries is because we are moving towards the era of the smartphone for smart industries or smart factories, where the industry people need to have the faster way of working of the machines, and the way of how you can able to apply the machine so that it will result in a good output with quality and precision. So that is the reason like the use of the hydraulics and pneumatics will matters a lot when you are having this type of the machines which will be used for the given purpose. So, but we'll see some things and then we'll show. So what is basically the hydraulic system? So last time, yesterday I told you, and I've shown you one video where I've shown you the hydraulic pack. So hydraulic pack is basically a circuit of hydraulics, which consists of the different components of the hydraulic system. Like if we compare it with the different components, like it is having the that motor, it is having the pump, it is having the reservoir in which the hydraulic oil is being filled up. Then that will be taken up to the different components, and then according to the pressure that is generated in the system, that particular components will move. So that is basically the things like how you can able to get the force that is being required to confine a fluid. Hydraulic systems are commonly used where mechanisms require large force and precise control. So as I told you earlier also, whenever we need to have the large force that is being needed in order to take up the heavy loads. Okay, like just like in the cranes. So cranes are being used in order to take up the heavy loads, and that heavy load is being transmitted and transported from one place to another. So that is basically the hydraulic load, and how you can able to control the speed, precise control of the speed can be possible when you can have the slow speed of the system. So that can be possible, and you can able to control the speed in a precise manner. Then hydraulic applications in manufacturing, transportation, and construction sector. So as I told you, I have given you the example of the aeroplane. So how the aeroplanes is being used and the landing gears. So landing gears is one of the good example of hydraulic system where when the aeroplane takes off and when the aeroplane lands. So hydraulic system which is being fitted with the landing gears that helps the wheels of the aeroplanes to come down and take up during the takeoff and the landing. And it will make the system more efficient, more systematic, and make the system more powerful. So it is being specifically used in machine tools and then the material handling devices, transport and other mobile equipments in the aviation systems. And examples which will include is power steering and brakes. Yesterday I had shown you the video of how the braking systems which will be there in the automobiles, in the vehicles. So what are the different components that is being there in the braking systems, and how the different braking systems will be used for this particular purpose, how it will be used for making the systems more efficient, what is basically the hydraulic jack is, and the earth moving equipment like the cranes and all, which will be used for the different applications. So what are the basic common examples of the hydraulic system? So yesterday I discussed with you about the vehicle brake hydraulic system, where you can see in the diagram also you are having a brake pedal. So when the operator or maybe the driver who is driving the vehicle, he will uh, make the brakes to be applied. Then you can see the master cylinder is there. That is one of the actuator. You can see how the oil is being filled up in the line, and then you are having the front brake calipers which is being fitted in order to make the proper movement of the that oil which will be filled up in the cylinder, and due to that the pressure force on the brake pads against the brake rotor is rotating the wheels. The wheels will slow down, the rotation of the wheels will slow down due to the friction that will be generated between the brake pad and the rotor, and that inclines that wheels to slow down and then stop. So that is basically the common example of the hydraulic system that is being there in this particular thing. Now, vehicle power steering. So what is basically the power steering is? The major advantage of using this system is to turn the vehicle's wheel with less effort. So if I will compare, if you see the vehicles which we are driving in the cars and all. So now a concept of the that power steering comes into application, like it is having the different system like the hydraulic pump, the power cylinder, and the control valve, which will be there. And whenever you are driving the car which is having the power steering, so that also is based on the hydraulic system, and its major advantage is like it will turn the vehicles with less effort. So the vehicle power steering system uses the hydraulic oil. Okay, so hydraulic oil is being used here in the vehicle power system. The hydraulic pump that is being supplied the oil through the control valve to the power cylinder makes the system to efficiently work, and you can have the very less effort with the help of which you can able to move your vehicle. In turn, you can turn your vehicle, you can speed up your vehicle, whatever you can able to do it with respect to the steering. So this is also one of the basic example of the vehicle hydraulic powered steering system. And then you are having hydraulic jack. So you can see here the example of the hydraulic jack. The major function of the hydraulic lift is to lift the high load with minimum effort. In a hydraulic jack, a small piston, pumping piston, transmits the pressure to the oil to a large power piston through a check valve. So if you see here the diagram of the hydraulic jack, you are having the oil reservoir, and then you are having the inlet check valve, which will allow the oil to move in any direction. And then you are having the component like it will be having the handle to operate the system. So when you operate it, you can see here the force through the oil makes this component to lift up with the having the weight, heavy weight, and then when the weight is removed, the oil will be released, and then you can have the platform through which it is moving up, it will be released down. So for this particular realization of the pressure and the exertion of the pressure, a check valve is being fitted so that it will make the oil to move in a right direction, so that you can have the system which will be more efficient, and it can be made easy in the sense like how it can be moved in one particular place. So that is the reason like how you can able to have the hydraulic jack, which is having the small piston and the pumping piston, and that will transmit the oil to large piston through a check valve. And then you have seen this type of the hydraulic jack system and all in the places where the mechanic or maybe any other persons, they are using it for the that maybe for lifting up the heavy loads, maybe for if the tire got punctured of the vehicle, then the particular person, maybe mechanic or maybe person who is driving the car, he is having the facility like the tire can be properly changed using this hydraulic jack. So you can able to lift up the overall chassis of through this hydraulic jack of the car by using this jack, and then you can able to fit your punctured tire repaired properly, and then you can able to fit it. So I'll show the video to you about 1 minute. I'll open the video first. So you can see, is this screen visible to everyone? Is this screen visible to everyone? Yes or no? ये screen दिख रही है सबको? Yes or no? Okay. So ultimately, this is a basic video of the highly automated manufacturing process for large aircraft structures in a dry CRPF design. So how in the CRPF, the design which will be taken up for the large aircraft, how the manufacturing is being done for that particular design, and how this manufacturing will be automated using the hydraulics and pneumatics as well as the electrical systems like robot and all. So you can see the video and you can observe the things, and then we will discuss it. After first you will see the video.
The Center for Lightweight Production Technology in Augsburg researches on innovative and industry-oriented automation solutions for manufacturing of large composite parts. The goal in the project ProTech NSR was to automate the manufacturing process of the rear pressure bulkhead of an aircraft, built from dry carbon fiber textiles. This structural part is about 5 meters in diameter and consists of many layers of carbon fiber textiles, such as long structural plies and complex reinforcing patches in double curved geometry. During the validation phase, all sub-processes were demonstrated. The first layers of the long structural plies are placed by rolling end effector, which applies the material directly from the material roll, draping it properly onto the double curved tool surface. The fixation of the plies is carried out by means of epoxy resin used for infiltration later on. This saves additional adhesive materials. The reinforcing patches are cut with automated and cutting machine. Lifted by a gripper and placed on movable transport table. Then the transfer to the robotic cell occurs. The modular gripper recognizes the shape and the exact position of the cut piece. The patch is autonomously approached by the gripper, picked by its 127 suction modules and transferred towards the tool. On the way, the modules are transformed into the target geometry of the placing position. The determined holding forces of the modules and the adjusted surface ensure the desired draping of the cut piece. Optical sensors within the modules monitor the quality of the draping process. Finally, the cut piece is placed in the target position. The quality of every applied cut piece is verified. For the inspection of the draping quality, a fiber angle camera is used. For the exact detection of the edges of the cut piece, a laser sensor with external positioning is used. The long structural plies can also be applied by two co-working robots. Therefore, both end effectors have to be adjusted to the target geometry of the tool. First, the current position of the modules is measured. Then the target configuration of the modules is set. Properly adjusted end effectors grip the long cut piece on each end and pre-drape it. An algorithm calculates autonomously the movement of both robots' collision free to the target position and sends the calculated path to the robotic cell, which executes the movement. the placing in the target position, the cut piece is draped and pressed on the surface. The in-house developed multi-kinematic gripper picks stringers as stiffening element automatically and after reorientation during the transfer places it on the preform on the exact position. Vacuum grippers on the free configurable manipulator arms ensure reliable holding of the stringer. They have to be positioned differently for every stringer that allow bringing all of the 8 stringers from the pickup station in the preform. For the fixation of the auxiliary material packages, the epoxy resin is applied. Based on a computer model as digital twin, the human-robot interaction during loading of the 3-dimensional pre-assembled auxiliary materials packages is coordinated. For this full-scale process, the robotic cell is particularly configured for safety regards. The collision-free robot paths are programmed and simulated offline. The manual loading of the auxiliary materials allows final quality check. The axis-synchronized movement of the manipulator arms allows an accurate and non-invasive placement adjusted to the target geometry of the auxiliary materials. In summary, the placing of all auxiliary material packages was successfully demonstrated. A semi-permeable membrane for VIP infusion with help of a mechanized system is placed in the tool and sealed circumferentially. At the end of the vacuum bagging, the membrane is compacted in the narrow radii by the multi-kinematic gripper. This occurs continuous and pressure-controlled normal to the tool surface. Finally, the preform is infiltrated with RTM epoxy resin and cured.
Okay, students, so you have seen that the various machines and the robots which are being used for making the aeroplanic structure of this type of the system, that is being required the hydraulic energy, and that hydraulic energy is being there with the help of the source that is called the oil, hydraulic oil, and that is being used in order to provide the large, or you can say the heavy weight transmission from one place to another. So that can be done using the hydraulic energy. So we'll move forward. Various applications like the stationary hydraulics, that's the system remains firmly fixed in one position. And if you see the mobile hydraulics, just now I have told you and I've shown you in the video also. For making the aeroplanic structures, you are having the use of the robots which can move and use the manufacturing, do the manufacturing at different places. So my mobile hydraulic systems move on wheels or tracks. So that is being used in production and assembly of vehicles of all types, machine tools and transfer lines, lifting and conveying devices, metal forming process, plastic machinery such as injection molding machines, rolling machines, lifts, food processing machinery, automatic handling equipment and robots, and the automobile tractors, aeroplanes, missile boats, etc. Construction and machinery, tippers, excavators, and elevating platforms, lifting and conveying devices, and agriculture machinery. These are the basic applications where you can have the two types of the hydraulics. One is the stationary hydraulics and the other is the mobile hydraulics. The stationary hydraulics is hydraulics which will remain first fixed in one place. Like you are having a machine that will be fixed in one place and then you can put there, the hydraulic system will work, making the different particular parts of the machine to work accordingly, move accordingly, and then it can give you the required output. And then you are having the mobile hydraulics, which will works on or moves on the wheels of the tracks and give you the motor movement of the different systems, and then that can be used for different applications. So if you see here in the picture, the industrial machinery that will provide the energy to control a wide range of industrial machinery and the equipment. And you can see the automotive machines like helping automotive manufacturing plants. Here in the ground side, aerospace industries like hydraulic ground support system that will be simulate in flight conditions for safety and reliability. And then in the industry, control and maintenance reliable paper production. Then printing machines that keep the printing press rolling. Automated packaging equipment really relies on precise control of pneumatics and hydraulic systems. Bottling of the finer things in the life, and you can have in the primary metal industries like fluid power, which is a backbone behind heavy industries such as steel. Let me show one more video to you so that it will be clear to you. Okay, so this is a video of the robot revolution, like how hydraulics and pneumatics, when it is being associated with the robot, comes up into the automation in the field of fashion technology, where the fabricants like the cloths and all are being made using this particular application of hydraulics and pneumatics. So just see the video and you can understand that how it is important.
The clothing industry is among the latest economic sectors to be making the leap, which is ironic because it was among the first to be mechanized. Today, they still require skilled human hands to guide and handle the materials. In this episode of Moving Upstream, our third on the robotics revolution, we're looking at what these new cutting-edge technologies can do and the impact they're beginning to have on the developing world. Across the globe, 60 million people toil each day in the garment industry. It offers the poor women in particular, job opportunities they might not have otherwise. The journal visited garment factories in Bangladesh. They employ more than 3.5 million people, most working for little more than the country's minimum wage, around $64 a month. And sometimes toiling under conditions that endanger their lives.
There has been another horrific incident at a garment factory in Bangladesh.
At least 112 people died.
Hundreds of injured were rushed from the scene.
Now a new threat is emerging to workers' livelihoods. Machines that automate parts of the clothes-making process. This German-made robot, for example, is knitting sweaters for brands like H&M and Zara. In January, WSJ's John Emont visited garment factories in Bangladesh.
I would visit factories in Dhaka where workers would work manually to make sweaters while automated machines would also work to do the exact same thing. And it was quite clear that the workers were going to be replaced by these machines. And I would ask the workers, are you afraid that your jobs will be taken away by the automated machines? And they would say, yes, we're scared.
Until recently, machines lacked the versatility, the dexterity to handle soft materials that comes naturally to humans. But thanks to machine learning and other forms of AI, what you're seeing here may be just the tip of the needle. New types of machines capable of ever more complex tasks are on the way. Machines like these threaten to make the situation worse for a country in dire need of more jobs. Bangladesh, according to the World Bank, needs to add 2 million jobs a year to keep pace with its expanding labor force. But the number of new jobs added by the garment trade has fallen to 60,000 a year. When you zoom out a bit, you see a region bursting at the seams with people needing work. Close to 1 million individuals are projected to enter the workforce here every month for the next 2 decades. By one estimate, if automation reaches its potential, some countries could lose more than 80% of their garment, textile, and apparel manufacturing jobs. How worried are you for countries like Bangladesh?
I'm very worried, given that their economy is dominated 85% by the garment industry.
Carrie Nordland, a professor at Brown University, teaches about the impact of globalization on women.
Because women have these jobs and often are the sole breadwinners for their families.
The sole breadwinners?
That's right. They've been able to lift their families out of the depths of poverty. Those low-skill jobs may become extinct very soon.
Eric Brynjolfsson, who studies the economic impact of what he calls the second machine age, thinks the only solution for these countries is education.
They're going to have to leapfrog and get up to the level that Europe, the United States, Japan, and other advanced countries have, and that's not an easy task. Technology can help there too. We have online programs at MIT.
Some of these people aren't even literate.
That's right.
So a lot of these women have very basic reading, basic math skills. So where will these women go? Will they have opportunities for retraining? This is the open question.
Fortunately for them, societies that employ massive armies of sewers still have some time. Autonomous sewing machines aren't nearly as far along as, say, autonomous vehicles. On a recent trip to Japan, we visited a company that's been taking intermediary steps in the autonomous direction. That's where we visited Yuho, a company that's been working for decades on the challenge of replacing sewing machines with machines that do the sewing. This is Akihisa Takagi, the 77-year-old founder and chairman of Yuho.
ミシンを踏んだことのない、触ったことのない人でも我々の機械ですと即そういう作業が行える。
Yuho's machines automate some of the more time-consuming steps.
この機械は自動でどんなパターン、このパターンがサイズとかいろんな形に多少形状が変わってもですね、サイズが変わっても自動でコンピューターでコントロールして縫ってしまう。
Yuho suggested that we visit a place where we could see some of its machines in actual practice. They sent us to a prison. What kind of uniforms are they making here?
刑務官の制服を縫製しています。
At Nagasaki Prison in Japan, Yuho's machines help the inmates, whose faces the prison authorities required us to blur, meet their daily quotas. And how much training do you need to be able to use one of these?
1日で十分ですね。
They use this one, for example, to add pockets to uniforms, a job that would otherwise take 3 people and a lot more time to complete. The inmates must produce at least 50 pairs of pants and coats per day. Yuho's owner tells us his machines are used in China, where labor costs are rising, to help make clothes for Uniqlo. But the developing world hasn't been all that interested, he says, because the price tag for them is so high. Cost is one reason why automation in the garment industry may take root first in the West. One US company called Software is aiming to do something Yuho has not, removing almost entirely human involvement in the process of making, to start with, t-shirts. The company provided this footage of its prototype Sobots. Software touts that its Sobots will bring garment production back to America. By the end of 2018, it plans to open a factory in Arkansas capable of cranking out over 1 million t-shirts a year. At prices the company says are on par with the lowest wage countries in the world. So the day when Sobots, from start to finish, can produce articles of clothing appears to be not so far upstream. What do you think? Will these technologies have a The automation revolution is beginning to come into fashion. The clothing Software is aiming to do something Yuho has not, removing almost entirely human involvement in the process of making, to start with, t-shirts. The company provided this footage of its prototype Sobots. Software touts that its Sobots will bring garment production back to America. By the end of 2018, it plans to open a factory in Arkansas capable of cranking out over 1 million t-shirts a year. At prices the company says are on par with the lowest wage countries in the world. So the day when Sobots, from start to finish, can produce articles of clothing appears to be not so far upstream. What do you think? Will these technologies have a dramatic impact on the US and on the developing world? We'd love to hear your comments.
Okay, students, so you have seen in the video like how the automation comes in the field of fashion technology, the cloth wear, the fabrication and all. So now mining and tunneling, offshore, power generation, sustainable power, these are some of the rapid applications where the hydraulics and pneumatic systems will be applicable. We will discuss it in the next lecture. So if anyone wants to ask anything, I'll just have a recap. So whatever I have discussed with you today, I have discussed with you today about the applications of the hydraulics, shown you the video also where I've shown you like how the hydraulics and pneumatics will be useful in the different application of robotics in the industries, how the hydraulics will take up the heavy loads, and given the example in the hydraulic lift, hydraulic jack and all, and then the different other applications which will be helpful for the different people to do. Then the aeroplane application in the video where how the in the aeroplanes manufacturing, how in today's time the manufacturing will be done using the automatic machines that is being based on the hydraulic system. So this is the things that is being discussed today. So next turn I will discuss other things like what are the other aspects of the hydraulic system, what are the things that is there in the hydraulic system, some basic small circuits diagram of the hydraulic system which will show you like how the hydraulic systems will work in a proper way using the different components, and when we just include the components in the circuit, how it will look and so on. So if anyone wants to ask anything, you can ask now, or if no, then give your attendance and you can leave the meeting. Quickly give your attendance and you can leave the meeting. Harsh, give your attendance quickly and you can leave the meeting. Harsh, give your attendance quickly and you can leave the meeting. Harsh. Harsh, give your attendance. Okay, students, thank you. I'm going to end the meeting.